Hello again, welcome to the second lesson in Chapter 2, Slope of a Line. Slope might be something that's familiar to you. If it's not familiar to you, don't worry about it. After this lesson, it will be totally familiar. So what is the slope of a line? It's basically the steepness of a line, and there's a couple ways to figure it out. So the slope of a line, it's a ratio. You can call it a fraction, because ratios are fractions too. And it's a ratio of the change in y, so we're talking y-axis, vertical movement, to the change in x-axis, horizontal movement, between 2 points, any 2 points on a line. The change in y, and there's this little triangle y, that's just because us mathematicians are too lazy to write change in. That takes a lot of effort, and plus we really like drawing shapes, so we decided to make change in a little triangle. I don't know why, it just is. So the change in y refers to the amount you move up or down to get from one point to the next, and the change in x refers to the amount you have to move left or right to get from one point to the next. Given 2 points, x1, y1, x2, y2 on a line, you can find the slope also. So basically today, we're going to find the slope of a line from a graph, from a table, and from 2 points. So you'll be using all 3 of these. They all represent the same thing, but some of them work better for others. So here we go. x1, y1, x2, y2, just to clarify, don't be alarmed when you see that. This little 1 and then little 2, it's just talking about the first point and the second point. That's all they mean. They're not like exponents that fell, okay? So first point, second point. A positive slope rises from the left to the right. So you see the cute little race car. I was so excited when I found that. Driving up, that's a positive slope. And if you see a line that falls from the left to the right, that would be a negative slope. So, finding the slope from a graph. First goal. So look at this side of your paper. Okay. Of those 3 ways to find the slope that I told you, the one that works best when you're trying to find the slope from a graph is the rise over the run. And I will warn you, a lot of times people get confused when you start finding slope because you're so used to plotting points on a graph using x then y, so doing the horizontal movement then the vertical. We're not plotting points. We're just looking for the slope of the line. So how do you get from one point to the next? And when you give someone directions of how to get from one point to the next, it has to be rise over the run, because again, it's the ratio of the change in y over the change in x. And with division, order matters. I'll probably play a little song for you in class to help you remember that it's rise over run. I'm not going to sing it now because I haven't had enough coffee yet. All right, so here's our first little graph, and I'm going to kind of show you all the different ways that you can get from one point to the next and show you that it doesn't really matter which 2 points you pick. So let's say I pick this point and this point on the graph, and I want to know the slope. I want to know what the steepness is. To get from here to here, the rise, I would have to go up 1, 2, 3. So that would be the numerator, the top, the rise. Now to get over, I have to go over 2. So that means my slope would be 3/2. And the good news is you get to leave it like that. You get to leave it all improper. If you get like 6/4 or something, I would definitely want you to have a simplified improper. So I guess it's not as improper as it is. I don't know. But you're allowed to leave it as a fraction because you want your slope to be a fraction. You will find out. So from here to here, yes, that would be 3/2. Now let's say you decided when you found your slope that you wanted to go from here to here and go down instead. Well, if you went from here to here, we'd have to go down 3, and movement down on the y represents a negative move. So you would have -3 if you move down on the y-axis, and then if you go left on the x-axis, that would be a -2. And guess what a negative divided by a negative is? Because that's a division problem. Isn't it a positive? So a -3 over a -2 will still simplify to 3/2. So it really doesn't matter what direction you move, they will all simplify to the same thing. One other thing, and this is where I think it gets super cool, hopefully you think so too. Let's say I want to go from this point to this point. I chose those 2 instead. To get from here to here, vertical movement first, I'd have to go up 1, 2, 3, 4, 5, 6. So my vertical movement would be a +6 because I'm going up. The horizontal movement to get from here to here would be 1, 2, 3, 4. Guess what 6/4 simplifies to? 3/2. So I'm not lying. No matter which 2 points you pick, they will always simplify to the same thing. And also, see how that's positive and the line is going up? Yes, you should have a positive slope if the line's going up. So that's a nice little checkpoint for you. And by the way, I just lost my pen. If you would have went from here to here and gone down 6, left 4, wouldn't -6 over -4 still simplify to, yes, you got it, 3/2. So no matter what you do, we can get our same exact slope. Let's try another one. All right, so I'm hoping you're seeing that, this line goes down, so I should end up with a negative slope. If not, you'll see at the end, that's what happens. So pick any 2 points. I'm going to pick this one and this one to start. If I'm going from here to here, my vertical movement, I'd have to go down 2. That would mean -2. And I'd have to go right 1, 2, 3, and right 3 is a +3. So I get a -2/3. Let's say that instead you wanted to go from here to here. If you went from here to here, you would go up 2, and you would have to go 1, 2, 3 to the left, which would be a -3. So if you, and these are division problems, right? If you divide a positive and a negative, no matter what order it's in, no matter which digit's greater, isn't it always negative? Yeah, so that's why you usually see the negative right in the middle there. It can go with either the 2 or the 3. It doesn't matter. It can't go with both because a negative divided by a negative would be a positive. So that's why it's usually written in the middle. And you can put it with one or the other. If I would have gone from, let's say, this point to this point, I would have had to go down to 4, which would be a -4. And I'd have to go to the right 2, 4, 6, which would be a +6. And yes, -4/6 simplifies to a -2/3. So again, no matter which way you choose to move, whatever moves you have, maybe you got moves like Jagger, they're all going to simplify to the same thing. All right, next page. Of course, we have some special cases because math is so special, isn't it? Okay, this doesn't look like your normal line, does it? If you were trying to figure out if this was a positive slope or a negative slope, it'd be pretty difficult because it's not going up, it's not going down. So let's just try to use our regular little method here of rise over run. If I am starting at this point and I move to this point, how far up do you go? You don't, so that would make it 0. And I could go right 2. 0 divided by 2, yes, that is 0. That one's allowed. 0's not allowed on the bottom, right? That's the undefined. But 0 divided by 2 is 0. If I would have gone from this point to this point, I would have gone up 0 and right 1, 2, 3, 4, which is still 0. So no matter what you do, if you have a horizontal line, and hopefully this makes sense, the slope of a horizontal line is 0. I mean, if they had a new roller coaster at Cedar Point and that's what it looked like, would you really want to go on it? Maybe if you hated roller coasters, you would. There is no slope. So instead of having to count, I wouldn't mind if you just saw a horizontal line and said, oh, that's a slope of 0. I'm good with that. On the other hand, take a look at this one. This is a vertical line. That is kind of like the dragster, right? Not quite, because I don't think, well, maybe it is. I can't remember the dimensions, what's going on with it, but pretty close. So this is straight up. So let's use our little formula, the rise over the run. If I picked these 2 points, I would have to go up 1, 2, 3, and I would go right 0. So if you take 3 divided by 0, you can't do that. Thou shall not divide by 0, remember? So this actually has a slope that is undefined. It's undefined. So if you see a vertical line like that, you should just know by looking at it, hey, that's undefined. There are no words for the slope of that line. And the reason is you can't divide by 0. Very good. Okay, so hopefully we know how to find the slope of a graph. Slope is rise over the run. Now we're going to look at finding the slope from 2 points on a graph. So I'm not actually going to give you the picture of the graph. I'm going to give you 2 points that are on the line of the solutions. And from those 2 points, you're going to be able to tell me what the slope is. So the formula that's going to work best for this is going to be this one. The y2 minus y1 over x2 minus x1. Basically, if you subtract your y's, if you take the difference between your y's, you're telling me how far up or down you have to move. And if you're taking the difference between the x's, you're telling me how far left or right you have to move. Order does matter when you subtract, so take the second one minus the first one. And make sure the y is in the numerator spot. It's the change in y over the change in x. So given this first set of ordered pairs, I have 4, 7, 8, 4. Zoom in a little bit. Now, first things first, this is x1, y1. This is x2, y2. Why? Because this is the first ordered pair and this is the second ordered pair. What I normally do so that I don't make mistakes, because I hate making mistakes, it drives me bonkers. We all do it, we're human, but I don't like it. I don't think anybody does. So what I usually do is I underline my x's and I circle my y's so I know I'm using the right numbers. And if we use the formula up here, it says to take the second y minus the first y. So the second y is 4, the first y is 7. And I'm supposed to divide that by the second x minus the first x. Once you have it set up, solve the top, solve the bottom, and simplify. So when you take 4 minus 7, yes, that's actually 4 plus negative 7 in disguise. That would be negative 3. 8 minus 4, higher minus lower, I'm not going to keep change it. You can if you'd like. But 8 minus 4 is 4. So I get a negative 3/4. You can write it that way, or you can put the negative smack dab in the middle. Either one is right. Okay, so for B, again, I'm going to do the underline circle thing. So there are my x's, there are my y's. To find the slope, I'm going to take the second y minus the first y, and the second x minus the first x. In that order, please. All right, well, 4 minus 8, or 4 plus negative 8, that's a negative 4. And 7 minus 1 is 6. Ooh, I know I'm allowed to leave it as a fraction, but not like this. You can simplify negative 4 6. They're both divisible by 2. 2 goes into 4 twice. 2 goes into 6 3 times. And yes, that was a negative. Ooh. So I'm going to put that right in the middle. If you wanted to put it with a numerator, you could. Usually you don't see it written with a denominator, but I guess it wouldn't be wrong. It's just you don't see it that way. All right, take a look at C once I get it back on the page. There we go. Again, I'm going to underline my x's. I'm going to circle my y's. To find the slope, I take the second y minus the first y, divided by the second x minus the first x. I get 4 minus 1 is 3. I get 2 minus 0 is 2. And remember I said you can leave it improper. Yes. So I'm going to leave this as 3/2. And I'm okay with that because usually if you're trying to find the slope from 2 points, it's because you want to use it to do a graph. And it's much easier to do the graph if it's in the form rise over run from the start. Okay, take a look at D. I am underlining my x's. I am circling my y's. I'm going to take y2 minus y1 over x2 minus x1. 7 minus 7 is 0. Negative 5 plus negative 7 is negative 12. 0 divided by negative 12, that's not the undefined one. You're allowed to take 0 divided by something. So this means my slope is 0. So hopefully you are picturing a horizontal line. It's going to look like that. All right, letter E. We're moving right along. Hopefully you're like, wow, this is super easy. So I'm going to underline my x's. I'm going to circle my y's. The change in y, negative 5 minus negative 3. Be careful on that. You're subtracting a negative. It's not negative 5 minus 3. It's negative 5 minus negative 3. And when I subtract my x's, it would be a negative 3 minus a negative 3. So when you do this one, negative 5 minus negative 3 is negative 2. And negative 3 plus a positive 3, or negative 3 minus negative 3, if you want to leave it that way, would be 0. The 0's in the denominator. Are you allowed to divide by 0? No! The 11th commandment, thou shalt not divide by 0. So this one has a slope that is undefined. I have no words for this slope. That means it's going to look like that, a lovely little vertical line. All right, last example for this, and then yes, we do have more. I know, it's crazy. So I'm going to underline my x's, circle my y's. y2 minus y1 over x2 minus x1. So I have a negative 1 minus 2, keep change, negative 3. 2 minus 5 becomes 2 plus negative 5, which is negative 3. And if you ever get that and it can come out to be a whole number, go ahead and write it as the whole number. Don't leave it as the fraction for this. So negative 3 divided by negative 3, of course, any number divided by itself is 1. So you have a slope of 1 for that one. So now, you know how to find the slope if you're given a graph, right? Rise over run. You know how to find the slope from 2 points. You take the second y minus the first y and divide that by the second x minus the first x. The last thing you need to know how to do is to find the slope if you're given a table. So turn the page. We're almost there. Okay, and again, when you're trying to, sorry, let me get my markers all situated. When you're trying to find the slope from a table, I again think that the easiest way to do this is just to use the change in y over the change in x. So triangle x, triangle y, change in, if you want to say it the long way. I'm trying to get it focused, sorry. And I think we got it all. Okay, so given a table for a linear function, you choose any 2 points from the table and use the slope formula to calculate the slope of a line. Because basically this x and this y, this means that when x is 1, y is 8, it's talking about an ordered pair. So 1, 8, that's one of the solutions that are on your graph. And when you see this, when x is 4, y is 6, when x is 7, y is 4, these are all ordered pairs that are given. So to figure out the slope, we learned that we can take the change in y and divide it by the change in x. So let's see what the change in y is from point to point and what the change in x is from point to point. So let's look at the first one. Here's the first y and here's the second y. And I told you before that you're supposed to take the change in y over the change in x, right? So if you go from point 2 and subtract point 1 from it, the y value would mean 6 minus 8. And if I'm looking at the x's, I need to use the same 2 points here. I would go from the second x to the first, that would be 4 minus 1. So 6 minus 8, or plus negative 8, is negative 2. 4 minus 1 is 3. That would mean that the slope of this is negative 2/3. And again, just like when you're doing the graph, you could use any 2 points that you wanted. Let's say that you wanted to use these 2 points instead. It will still work. So here's the first y and the second y. I'm going to take 2 minus 6, and then I'm going to start with the second x minus the first x. That would be 10 minus 4. 2 minus 6 is negative 4. 10 minus 4 is 6. And doesn't negative 4 6 simplify to negative 2/3? Yes, so no matter which 2 points you pick, when you take the second y minus the first and the second x minus the first and simplify it, it will all simplify to the same exact thing. And remember we talked about a constant rate of change. Do you see how x, the croc, you go from 1 to 4, that's up 3. 4 plus 3 is 7. 7 plus 3 is 10. So there's a constant rate of change here because here it's going down by 2, down by 2, down by 2. So the change in x is the same, the change in y is the same. That's a croc. That's what I'm referring to. We'll talk a lot more about that. Not today. All right, one more table. Well, actually 2 more because I need to show you that it can be written in a different way. So let's just use the first set. Why not? The change in y's would be 5 minus 2. The change in x would be 3 minus 1. 5 minus 2 is 3. 3 minus 1 is 2. And I told you before, you can leave it just like that. Totally fine. It's improper, but it's simplified improper. One more of the tables. Okay, this one's written differently. It's not any different than the rest. Here are my x's, here are my y's. These are just like ordered pairs on the graph. Right? Do you see that relationship? So when I gave you 2 points, you just took the second y minus the first y and divided that by the second x minus the first x. Again, be careful when the second digit is negative. It's not negative 2 minus 3, it's negative 2 minus negative 3. So add the opposite here, that's negative 2. Add the opposite here, that's a 1. And if you can write it as a whole number, please do so. We'll put it back over 1 if we're going to graph it, which will happen soon. So negative 2 divided by 1 is a negative 2. And that's how you find the slope from a table. So it's basically the same as the 2 points. It's just written differently. So in summary, I give you a nice little picture here. And this is another one that I found with the race cars in the same kind of spot. It was an exciting clip art day. If I give you a line that's horizontal, that's a 0 slope line. If you see a vertical line, vertical line has an undefined slope. There are no words for the slope of this. Just like if you went on a roller coaster like that, you'd probably have no words other than, ah! So undefined. If the line heads on up from left to right, that's a positive slope. And if the line heads on down from the left to the right, that would be a negative slope. You are done. I'll see you tomorrow.